In this class, we learn about tolerances. Generally, dimensioning and tolerances both goes together, and it is called as GD and T, general dimensioning and tolerance. General dimensioning, I have already explained you in the previous classes, and now tolerancing, I will explain now how it is done in AutoCAD. See, this chapter particularly is very important for mechanical engineers who draw machine parts and who design machines. Okay, and it is necessary to fix tolerances on shaft diameter and bore diameter or bearing bore or shaft diameter. This is particularly important because when in a bearing which has a bore, inside that a shaft is running, it should run freely, and at the same time it should do not have any extra clearance. Or for example, a hydraulic cylinder. In a hydraulic cylinder, the piston will run very close tolerances, and it will not allow the oil to escape, and or air, if it is a pneumatic system, is the air to escape the other side, but at the same time it moves. That means there should be just enough clearance between the bore of the cylinder and diameter of the piston to move just only, and nothing should escape from there. Oil or air should not escape from there. From this point of view, and many more places, the joints, particularly machine joints, they should run very closely or they should rotate very closely. And for these purposes, we have to manufacture the parts to a very close tolerances. That is, to the diameter and bore should have very minimum clearance or optimum clearance, we say. In some cases where the ball bearings are there, then inside the bore of the ball bearing, a shaft is fitted. So in that case, the ball bearing bore should be slightly smaller than the diameter of the shaft, so that we can form a press fit. So these things about the tolerances, any one mechanical engineer should know about the limits and fits, the basic limits and fits. I will just show you a table how the limits and fits chart looks like. See, this is the limits and fits. This is a standard. It is in the ISO standard or in the British standards. What is given here? There is a system hole and transition shaft. There are two types of fits and limits and fits. One is bore basis, that is hole basis. The other one is shaft basis. In the hole basis, the hole is fixed as a standard and shaft diameter will be changed. Of course, these things are not relevant to the AutoCAD drawing, but I just give you a brief background of these things. This is how the table looks, limits and fit table. See, tolerance limit in millimeter. This is the diameter, 1 to 3 mm diameter for bore or a shaft, 6 mm, like that, 400 to 500. This is mentioned in ISO standard, and these tolerances are, symbols are D11, E7, E8, F7, like that various, and this is called the running fit, D11, E7, E8. These are all small letters. Lowercase letters are shaft diameters, whereas uppercase letters are bore diameter here. These are the bore tolerances, and these are the shaft tolerances. Combining the bore tolerance and shaft tolerance, we can get either a press fit or a running fit or a clearance fit, depending upon how much minimum and maximum clearance is there. See, here this is classified as large minimum clearance, with medium minimum clearance, with small minimum clearance, with the smallest minimum clearance. This is the running fit. It means the shaft will rotate freely inside a bore which will have certain bore diameter and its diameter is also limited within certain dimensions. Similarly, transition fit, this is slide fit when it has to move. That, for example, I took an example of a cylinder and a piston inside. It has to move inside. This is the tolerance of the diameter of the pistons. You can select it depending upon your design, and push fit in keys and all that. When you have a key on the shaft, it should be pushed one side. It should be easily inside the gear, and so on the gear side slot, it should have certain dimension, and the key width should be such that we should be able to push it to fit it. Ring fit, this is also slightly tighter. It should not rotate. And this is tight fit secure. It will not rotate and it will just slide. Tight fit. And then this is interference fit. There will be interference, particularly in case of ball bearings, where inside the bore we have to fit a shaft, and the inner race will rotate between the ball and the outer race. Okay. Base hole, this is the hole sizes, and fits are formed by selecting any one of these things in the shaft side, and one of these things in the bore side. See, this is 1 to 3 mm, 3 to 6 mm, 6 to 10 mm, 10 like that. So, see, these are the dimensions, variations in shaft size. Minus 0.2 mm, that means it is micron. 0.001 is 1 micron, and 0.02 is 20 micron, and 0.08 is 80 micron. That means the shaft, suppose the shaft has a diameter of 3, it can be machined to a size either less than 20 micron or further less than minus 80 micron. It should not be on press side at all. Similarly, this is, so for example, this side, 180 to 50, this is 0.17 minus side and 0.46 in the plus side, that is 170 micron or 60 micron. Similarly, various fits are given, you study in detail. And here, similarly for the bore should be plus side, plus 006, 6 micron in case of H6, and it should be 00 on the other side. That is, it should be machined within this limit. Suppose the size of the bore, for example, we consider 180 bore, it should have a size 180 minus 180 plus 0.025, one size, or another size 180. That means it should be ground to a size somewhere between 180.025 and 180. Similarly, here it is 180.029 and 180. So like that in many places. If minus is there, it will be in a minus side. Okay, I just briefly described the tolerance. And here on shaft basis, here the shaft is fixed as a major, standard, and holes are fixed as variable. If shaft is variable, holes are fixed as fixed standard. Okay, so for further details, you have to read limits and tolerances, fits, etc. Now, next one is, this is surface finish. This is also comes in AutoCAD, representation of surface finishes. And see, any component cannot be machined, to be machined to an absolute accuracy. Suppose if the diameter has to be 120 mm or the length has to be 100 mm, it cannot be exact 100.000. But it will be slight variation depending upon the machining you do, and how much you can tolerate. That is called as variation. How much you can tolerate in our machine parts, that is called as tolerances. So here the surface finish, the finish of the component should have certain values. That is, it may be rough if it is using for rough work, or it may be fine finish if a shaft is rotating inside a bush at high speed. The shaft diameter should be ground, and sometimes it should have a super finish. These are all RA in microns. You can study the books, what is meant by microns and all that. This is 0.012 micron. This is 12 micron. This is 0.012 This is 0.25, 0.5, 0.1, 0.1, 0.4. This is the surface finish variations. It cannot vary more than this. Surface finish. This is 6.3 micron. The point is, this is micron. Whatever you studied in tolerance is 0.0, that is in millimeter. This is all in millimeter, whereas this is in microns I have given you. So the surface finish means it's a variation in the surface, ups and downs and variform. That should be top crust and bottom crust should be within these values. Here I have given castings, shaping machine, whatever you have done, machining and machining gears, and what are the we can achieve by various types of machining is also mentioned here. So this is about a brief overview of limits and fits and tolerances. Now come to our regular AutoCAD. So if you refer AutoCAD, we have one, we shall make one drawing. From that, I will be able to explain you very clearly. So this is the point at, say, 500 mm, 0. So I will change this. I have already layers created. I will first make component in the 0 layer. Made it 5000 mm. And this I will make it say 500, 250. I made a round figure so that you will understand very clearly. Or I will increase it. Increased. This is how it looks. Trim command. And I will draw the center line. Any component if you draw, it should have a center line. I can draw a center line. And this I can convert into center by layer. Okay. Now I will draw a circle to show the side view. And if you type perpendicular or select the snap mode PR here, and you see it is to that diameter. If it's a perpendicular, it is that diameter. And I will extend this. Extend this. Then I will trim out the whole thing. This also I will change it to center line. So I will save this. This is the, let us say this is a shaft. And now there is a bearing. I will represent a bearing. Diameter I will say. Oh, it is too much. Will further reduce. This is the diameter bearing. And bearing will have a hole. Yeah, it's a simple bush bearing, let us say. And hole, its diameter is design size will be the same as this diameter, and we can draw that. Draw like this, a line, a circle, perpendicular to that. This is the hole. So the side view of this. The bearing in bushes will be smaller, so I will say 500 like this. Trim this. See, sometimes typing will be more easier than selecting from the toolbar menu or shortcut menu, because if you're not very much familiar, you may keep on searching for that. Of course, keep on making drawing the same setup. You will be easily able to identify the shortcut menu's position, which I explained to you in the last class also. And now I have to draw a center line for this. Center line here also. I will change layer. Center. Okay. Now this is a bearing. Right here. If you want, I will make it. This is a shaft. Size is bigger so that you can see it. We can increase the size by making it. Everything lies in the same line. We can change it, manipulate. Now we have two components. One is the shaft, another one is bearing bush, or a bearing. We can call a bearing bush bearing. You can say it is a bush bearing. We'll call it in a different way. That will be better, bush bearing. Because ball bearing is also there. This is a bush bearing. This is called bush bearing. Now, this shaft has to run inside this hole. Okay, I will make a hole also. assume that this is a section. I have taken a section and showing you the side view. So this is how it looks. Now, this shaft has to run inside this bush bearing. The design size for both the shaft body and the bush board remains the same, but the accuracy with which these are manufactured and the exact size to which it is manufactured depends on how it is fitted inside the bush or how it is fitted inside the other. So suppose it is a running fit, it will have certain clearance, and if it is a tight fit, it will have some other clearance. It will have suppose some slide fit, it will have some other clearance, like that. And if you want to run it at a very high speed, the running clearance will be very small, and surface finish also should be very good. So this is how it will be decided. Now, so we will dimension it first. Before dimension, we should know how it should be. Suppose we assume it is a running fit. So then what we can do is, I will explain, and then you can practice on your own and use whatever tolerance is applicable. Here, in this case, small icon. See, here we will see the diameter. The diameter is how much we draw the diameter. I will just draw the size so that we know about it. It's very small, so we will select a bigger font. So go to the dimension where this is ISO 25. So I have ISO 25. I'll change the size now. So automatically it will get changed. Dimension, style, dimension, style, ISO 25. I will modify to 2.5. I will make it 25. Okay. This also I will make it 20. So other things, let it be, I need not change, let it be as it is. So now we will dimension it first, then we will come to transparency. I think you can see this now. This is 1000 diameter, the shaft body. Here, similarly, the design size, this is also 1000 diameter. It has to run inside. Only you have to keep some clearance. So dimension layer I will create some different way. It's better to understand. Dimension layer I will make it. I change the layer dimensions. Okay. I think the font is very small. I will further increase it. Better. Say I will make it 100. This I will make it 80. Now let us see. Like this you have to select. By practicing you will know. See now we can see this. And style also we can change so that the dimension will come in between. See, it is over the line, and that you can practice. You can know it will save some space. So I have to lines, I have to consider arrows, text, fit. Here either text arrows between them and base dimension. Okay, then the lines, arrow symbols. We have to select somewhere. Draw frame, see here, we'll change. It is centered, we'll make it centered. This is also centered, let it be. So it is centered. So the length also we will fix. We will dimension the length. For simplicity, this is the length. And here the bearing thickness or width or length, whatever we call, this is also 500 mm. Can change. Like this. This shaft. Now we have dimensioned the drawing to the extent it is possible. If you want, you can fix the OD also. And this is also we can dimension. So I'll just show you how we can dimension. So this shaft has to run inside this bush, and it has to be manufactured to certain tolerances. I have shown you the limits and see this diameter is 1000. Here it's just recommended just a nominal diameter. For simplicity, we have selected some arbitrary diameter. Here the limit is only up to 500 mm. See, there are special limits above 1000 mm diameter also, but I have not. I do not have the standard, and I have 500. So I will fix up the 500. Assume that this is a 500 shaft, or fix the same diameter for 1000. We are fixing the same. So it is a running fit. Suppose you want to run with the bush is with a large clearance, then it should have 0.23 minus side, 0.630 minus side. That is the shaft I am talking about. And with running fit, with which fit should form? It can form running fit with H6 or H7 or H8, H9, H11. Any of these things it will form a running fit, but the fit will be different. Suppose the bore we select this, the clearance will be more. We select the clearance will be lesser, and we select this, the clearance could be more. I will explain you that. Now, so I will take up with a large clearance. See, this I will take it as D11. So this is 0.230 minus 0.630. 630. Now you go to dimension, or there is a command also on the command line, DIM TOL. If you type, it is off. We have to type this. We have to make it on. Then only dimensions can be specified. Either you can switch on here, or you can go to dimension command, style, and possibly somewhere it is here. Tolerances, you go there. Now I have already switched on. And units, decimal size, you can say 0.00. Tolerances, it's just symmetrical. There are three types of tolerances here. None, symmetrical. If it is equally from the center line, that is 0.1 plus or 0.1 minus. Deviation, how much it deviates from the center line, and its limit is the actual sizes we can put. And this is the basic size. Basic size, we will explain one by one. None, the tolerance is on, I have made it on. So, and now we have to dimension the component. So we have taken 0.2.63. Both are minus, minus 2.63. What you have to do here, go to tolerance. So first we will make symmetrical upper value. Symmetrical, it means equal, so only once you are writing. So since it is not symmetrical, we are selecting deviation. So upper value, it deviates from the standard design, say 0.23. and lower value it is 0.63. This is not correct. Actually, upper value should be, see, it shows plus sign. So you will take minus because this is given minus. And lower value is always minus. Here you can know it. When you display it, you will know about 0.63. And precision 0.00, 0.00. If you select 0, there will not be precision, it will not project. It is only 0.1 it shows. So if you projection 0.1, 0.0, it will only give 0.2. 3 will be rejected. Similarly, 0.6 it shows. Now normally for dimension at least we should take 0.00. And scaling height, the dimension size of the digit should be less than the actual dimension text height. So here the dimension text height, we can make it normally 60%. That is 0.6 you can write. Vertical position, bottom, see here, bottom, this one is at the bottom, this is at the top. And middle, see both of them in between. So this is top one, bottom one. And then top, see the top dimension here and bottom dimensions. Here you can fix the alignment as you did. So align operational symbol, that you will leave it. And now, so then you click on this. And then you close. Now I will dimension it once again. I switched on. See, this you have to see, dimension tall is on now. So suppose dimensioning, you have to, automatically you have to dimension, linear dimensioning, select this point, select this point, select this point. See, it has come up, we have selected middle. Yes. So I will make this. Okay, this is up, the diameter. Dimension is known. So the length is you don't require dimension tolerance, so you can dimension DOL off, you can say. Then you can dimension this like this. This is how you can do it. And here, this is a diameter. For indication of the diameter, what we have to do is you write 5. So like this, you put a value, you put a symbol, percentage twice, see, it is 5. So this indicates the diameter. This is how the shop OD is dimensioned. And of course, here you can select the gap and all. Last time I have explained in dimensioning, all that you can select as you wish, 1 mm or 2 mm, the gap between this edge point and this point and this. Here it is very close, but you can make it bigger by selecting that in the menu. Similarly, here the dimension have to change. This bore only we have to tolerance the bore. How we are going to do it, let us see. See, I am going to make this bore to H7, let us say, H7. So here is plus 0.063 and plus 00. So 0.063 plus 0.063 plus 0.00. So now, once again, dimension tall, switch on. This you have to do frequently if you are dimensioning. And then you go to the menu here, or here itself you can type DIM TP. TP is the upper level tolerance. You want to be 0.063. You can type 0.063. And DIM, TM is the lower dimension. It is 0. You can type 0. And you go there, I will show you how it has appeared. See, it is 0.6. Here I have to tolerance. Here I can change it. Upper value 0.63. 3 will be rejected. COI value is 0. Scale is 6. This I think I have typed wrongly there. That's why it has come out as 0.63. Suppose I type, whatever I type here, the same thing will appear. I will show you once again. TP. See, I have typed 0.63. 0.063. And TIM. It is 0.0. Okay, now I will show you here how it has come out. See, something is there. Now tolerance, deviation is there, precision 0, 0. Now you can dimension. So here it is the middle, that you have to see, middle is already there. Precision is, tolerance precision is 2 digits. Okay, third one it will reject, no problem. But if you want to 3, you have to make 3 digits of precision. I will make 3, I will show you for your first example, I will show you that. 3 if you want, because here the tolerance is up to third digit, so what you make it? 3. Okay? Click. See here, possibly the other dimension also, this is not changed, because once we dimension it will not change once again. So, it will not take the effect. Once again, you go here, click here, click here, click here, click here. See 0.063, 0. And you can select the dimension command. And we introduce 5 here. This is how it has to be. So that means I will explain you the maximum clearance and minimum clearance. See, this shaft can be manufactured, ground, to the size of 900,000 minus 0.23. It can be manufactured 999.77, or it can be manufactured to the size minus 0.63, 997.37. It will be 997.77 or 999.37. Size will be there. Okay. Then this will be manufactured to the 1000. Either 1000 mm, 1000.603. So you can calculate the minimum and maximum tolerance. See, here it is the minimum size will be 997.37, and here is the maximum size is 1000.63. So the difference you can find out is 1000.063 minus 997.37. It will have a clearance of 0.693. That is the maximum clearance you can have. And minimum clearance will be, that is the maximum clearance. Minimum clearance will be, see here. We have to, this shaft can be, maximum diameter can be 1000 minus 0.23. That is 1000 minus 0.23. This is 997.77 minus 1000. So that means you can have a minimum of 0.23. 0.23 or 0.69. Variation in the clearance is, maximum clearance is 0.69 and our minimum clearance is 0.23. So the shaft will be within the clearance, it's always having a clearance so that it can run. But it is a rough running. So if you want very slow speed, it can run. If you want to high speed, the clearance should be made very small. It can be made as small as 0 or 2. 0 20 micron, 0.02 can be made. So then the process you have to adapt to different machining process, grinding or machining, super finishing, some such mechanical processes to be adapted. Same way to the bore also we have to adapt. Okay, this is how we can do tolerance. And lengthwise, normally we don't tolerate. Lengthwise also we can suppose length you want to constrain 500 mm within certain limit. So what you do is you erase this. Once again you go to tolerance, on, it is on. And here you take, here you do it. Say length you want to control within 0.5. And lower limit is also 0. Say lower limit is 1, let us say. So lower limit is always negative side. That you have to keep in mind. It is not just a numerical value, it is always in the negative side. See. This you can see. Similarly, length there also if you want to control. This is how we can do tolerancing. Now, we have learned about tolerancing, but we also have to know about the finish. There are some symbols for finishing the finishing symbols are there, and so many other tolerance symbols are there. How the shafts will be running and all those things. So here I will explain you the surface finish. What are the symbols? And the surface finish symbol, I will just show you. It is triangle. See, you know that you might have studied in your classes that 3 triangle is ground finish, single triangle is here of course it gives only certain finishes. Generally, you have to mention these finishes. These values you have to mention. Making a tick on that, you have to mention these values. These are these icons have been stored in the AutoCAD, but it takes a lot of time. You have to learn for yourself. To explain you here takes more time, so I will briefly explain you other aspects. See, the shaft when the shaft should be manufactured such that it should not be oval, it should be concentric. Or in the ovality should be it should not be oval. That means the diameter should not be elliptical, but at the same time it cannot be absolute cylindrical. But you can limit the things within certain value. Here is a command. See, this is tolerance. Create geometrical tolerance contain the feature control. This is how. This tolerance. So this, if you click, you will get a screen pop-up menu here, and here symbol. If you click on this, you will get a symbol. You want the shaft should be oval, that is cylindrical. This is cylindrical symbol. This is parallel symbol. This is equal symbol. This is perpendicular symbol. This is concentric, and this is angular. This is once again surface. This is surface series. This is arrow mark. This arc how much it be. Like that, different symbols are there. Suppose I select the circularity is this. It will mark there. How much it should be? The circularity should be within 0.01 mm. Let us see. 0.01. Tolerance to we need not give here because not required. 0.02. Here 2 limits will be given there, and height, control frame, the projected tolerance zone, control variation height on the extended portion of the fixed purple bar. So this is the height it gets. So we will see without any height what is going to happen. So tolerance is overlay should be within 0. That is sufficient for us. And you click here, you get a screen. So what you do is type here. This is in symbol you get. What you do is like this. Take an arrow like this. Join. So you have to make it rectangular. Do like this. Yes. and you have to take another line that is from the center. With the axis, it should be over. That is the meaning. Click like this. Okay. The sizes you can adjust as you see now where height is given, height and all that modifying it. You can modify it if you want. Yeah. Where is it? Here you can hide projected tone zone, etc. You can modify. Okay. This is how you can represent. It should be woven within the. And so, suppose the shaft is this bore, it should be. Suppose the outside bore is also having certain tolerance, and it is fixed in a housing, let us say, the bush outside, or let's say it is a ball bearing. Let us say it is a ball bearing. The outside diameter also should have certain tolerances. So what we do, we fix up outside tolerance. Wood should also have some tolerance. So arbitrarily we will fix up some value. See, I will take up the value here. See, 0.5. Let it be anything. It is not so wide tolerance, it will be closer, but for our explanation purpose, I will take some tolerance. See, outside is also fixed. But there is one important factor. With this axis, this bore and the OD should be coaxial or concentric. Within what value? You cannot be 100% concentric, but it has to be concentric with certain limit. So that you can judge based on the purpose you need and with your knowledge. And here, if I click here, the symbol will be this concentric. Okay, this means both this whole to be concentric. You click on this. Say you want to be within 0.02, let us say. You will get this. Somewhere you can place. You can make a line, or you better to place. So this will as a complete entity. It is not a individual line. It is simply a block. You can click somewhere here. So you want with this bore, we draw it from here, it's central line. If you take normally better to take central line. You can mark arrow this side or that side, doesn't matter. See, this and another hole, it should be concentric with the hole. Take from here, take from here, take from here. You can either join here or you can join to this end. This is how. That is, it is concentric within 0. That is if you fix a standard inspection manual and run a dial over it, the dial will not vary more than 0.02 mm. And the line here is crossing, and you can, last time I told you, break command you can use, and you make a break here. Somewhere we use the command for breaking a line. I think this is the break, and you can select. See if it has broken. Okay. So this is how we can do. So one sample example, I explain other things we have to follow. This zone can be transferred. Suppose it has to be square, the surface to be, this body and the surface to be square, that is, should be flat. See, I will show you the symbol. This is the perpendicular here, this is the symbol. So this face and this axis should be perpendicular. Then you have to take this symbol. And you have to say how much perpendicular. Say 0.01, let us say. Then you click it. face somewhere, and you can do like this, and then you can use shortcut menu everywhere so that it is easier for you. Like this, and it should perpendicularly OD, outer diameter, or the axis. So what you have to do is you take a line here, American line, like this. It indicates that these faces are perpendicular to another. Of course, the layer you can change if you want to any layer you need, like this. If it is the tolerance you want to mention the layers, you can select the entire thing and change the layer. This is how you can do tolerance. Now, we have different methods of expressing the tolerances. We will see here. So now I have discussed about the deviation, how much it deviates from design side or nominal side, how much plus side, how much should be minus side. And there are different ways of expressing. Symmetrical. Symmetrical, I told you, it should be plus or minus equal on either side projected. So this is only in very rare cases. Deviation. See here. Deviation. See here you can see closely how much it deviates. That's what we just now we saw. Deviation, and at the same time limits. So this is the limit actual values it will give. So there are two methods. One is deviation from the design. Deviation from the design, it gives tolerance at H7, H7, you can select like that. And other one is the limits. It gives the limits. See, you have already fixed the tolerances, upper value, lower value, you have to fix up anyway. So once you fix up the upper value and lower value, you can always select the limits and we can put the tolerance. I will just make a demo of how we can do the limit tolerances. I will erase this and make it as a limit tolerance. Now, how much we kept it that time? 0.23, 0.63. Point upper value minus 0.23 because it was minus, and lower value 0.63. Lower value is always minus, so lower value is put it 0.63 only. Okay, suppose you put lower value minus 0.63, already minus is assumed for the lower value, minus of minus by plus. Similarly, upper value if you put plus 0.23, it becomes plus only. Okay, then you can click on this because we have selected the limits there, and now you can dimension it and tolerance it. See, our dimension it. See. So the actual values is projected here. See? So the computer itself will calculate the value and displace it. Okay. This is a layman is working in the shop floor, then this will be a better method because he knows the dimension. Or a man, any man working in the shop floor, this is a better method because he knows the dimension within what value he has to measure it, which is to this size. Otherwise, he has to calculate plus, minus, and all that. Similarly, I can change here. Now I will go there. Modify, go there. And this is how much it is. Oh, not. 0.063. One is plus 0.063, 63, and other one is 0. Okay, I kept the limit as it is. Click, click. Now I will erase this. You can type it manually also, but written you have to press. See, like this, you have to finish it. Manually you can. See, it is 1000.06 because it's only 2 digits you have marked, so it has not taken the third one. 3 digits accuracy precision should have been 3 digits, then it would have taken the third one. It is as it is. This is how the tolerances can be made. So there are 2 methods. Suppose it is only plus or minus, then one plus or minus indicates. I will just show you. For example, you want the say this length should be plus or minus 1 mm. Then what I do is either type mm or you go there, select tolerance, click here, you select symmetrical, then only one it projects. Suppose you give 0.5. Now you can dimension it. This will eliminate it. See, I show you. This size we have selected 0.6, which is 0.6 of this height. So this I can change, this I can make it. These tolerances can also be edited. If you don't want, you can remove it. But the tolerances normally is not. And font size also can be changed. Anything can be done. If you change font size, we have to standard. You can change to some other type. Annotative is there that I have told you. I will explain you later on when we do printing. At that time, I will explain what is annotative. So this is how we can do tolerances. So if it is equally plus or minus an equal number on either side of the design size, then you have to select limit, what is that, deviation. What we have mentioned it. See, it is called symmetrical tolerance. There are 3 types of tolerance: symmetrical, deviation, limits. Basic, you don't worry about basic now. Not required that. Basic tolerance. These 3 is enough if you know. This is not necessary. So I have told you how to use symbols and all that. And surface finish can be expressed. For that you can create a triangle. Its sizes you have to decide. Equilateral triangle. Make an equilateral triangle. These things you can always which is not an equilateral. Approximately we do it. This is a symbol we use for, we will scale it so that it will be small, proportion to the drawing. It should be slightly smaller than the tolerance text. So let it be. And suppose a single symbol indicates that it is rough, that is rough machine. So what we do is normally this symbol can always on the line. But it should not be on the OD of the shaft. Normally we put it outside. And suppose you want double, we'll extend this. Like this. Okay. And if you want grinding, you can put 3. So we'll do outside, you will have finish. We will have 3 because the shaft should be ground. This. And then for the bore, you can have copy that thing. Or you can fix it here, like this. Of course, I am supposed to hatch it, I hatch it. User defined, I will select. The cut section should be hatched, I will hatch it. And spacing, I will take it as 10. Okay. And none. So this is shafts. One more thing I have to mention here. The shaft will not be sharp. It will be chamfer. You know the chamfer command, you can always chamfer the shafts. I am not explaining here, I have already explained it earlier. So this is how tolerance can be made. Basically, you should know some basics of tolerance, limits and fits. And the knowledge of drawing, process drawing or whatever may be the type of drawing. You have that knowledge you should have. So now we have finished. Symbols and all I have shown you. Anything is left? Nothing. So we will see anything is left here. Yes. Of course, tiles also we can set as you have. One more thing is important. This primary unit is mm. So alternate unit also you can mention. Suppose you want primary unit as, so here it is a millimeter. Alternate unit, you can place alternate unit here. So it's already, suppose you want to have engineering or inches, we'll say, inches. So you can say, you have to convert it to a value, say 0.05, multiple of more units. So what is the multiple of inches? That you mention it here. Round out distance is 0. So 0.04 is 0.1 inch, 0.4 mm. See, you should know how much it is. Say here, 25.5.4 mm is equal to 1 inch. So if it has to convert it to inches, it is 1 divided by 25.4, 003.03. So you have to, value you have to mention there, and then you mention here, this. And then suppose we dimension it, it gives you inch values. Inside the bracket, you give another inch value. Suppose I do it here, say 16 inch, etc. I use tolerance also for that. So all dimensions will be given like that only. Here also, in case you give, if you pick the inch values like this. Here, this alternative is. Tolerance we need not fix. I think here these things we have fixed already. Symbol, arrow size. Other things I have explained you earlier. This is about the tolerances. So we'll almost now we are ready to draw complete drawing with tolerances, and you can dimension also, and you can take sections. Your original knowledge should be able to deal with how to take sections and all that. You have to draw it accordingly. Okay, so I think I will end this class now.